the fundamental theorem of calculus. In this section, we discover how net area and antiderivatives are related. Let f be a continuous function. Let a be the definite integral from little a to x. Then a gives the net area of the region bounded by the graph of f and the t-axis on the interval a to x. Is it possible to find the derivative of the function a? If so, what is it? The fundamental theorem of calculus part 1 says that the derivative of a is equal to f. So the area function of f is an antiderivative of f. This leads to a very important and useful result. So this next slide I give you is very important. If f is continuous on interval a, b, and big F is any antiderivative of little f, then the definite integral of little f from a to b is equal to big F evaluated at b minus big F evaluated at a. Do you remember finding the net area using Riemann sums? It was a long, tedious process. We got an answer of 6, but it took us a long time. Finding net area is going to be much simpler now. Let me show you what to do. You first find an antiderivative of the given function. Then you evaluate the antiderivative at the top number and at the bottom number. And then you find the difference. Notice that it's big F evaluated at the top number minus big F evaluated at the bottom number. So it's top minus bottom. We find an antiderivative. Notice that we don't need plus c, and that's because we only need one antiderivative. We don't need all of them. Then evaluate and find the difference. We get the same answer of 6. Let's do another example. Find the antiderivative, and then notice your bounds. I'm going from 0 to 10. Before I evaluate, I simplify the expression. Then I go expression evaluated at 10 minus expression evaluated at 0, and I get 1,000. Let's do another example. Find the antiderivative. What are your bounds? Now evaluate. Cosine of 2 pi is equal to 1. Cosine of 0 is equal to 1. So I have negative 3 minus a negative 3, 0. If you look at the graph of 3 sine x going from 0 to 2 pi, you can see why we got an answer of 0. The area above the curve is equal to the area below, the area above the x-axis is equal to the area below the x-axis. Let's do another example. For antiderivatives, there is no product rule and no quotient rule. So when the integrand is a product or a quotient, try simplifying the expression before proceeding. I break my quotient up into 2 separate quotients. And then I simplify each quotient. Now I want to be able to use the power rule. So I'm going to rewrite 1 over radical t as t to the negative 1/2. By doing that, I can find the antiderivative using the power rule. So find the antiderivative. Before you evaluate, simplify. I also switched back to radical notation, but you don't have to do that if you don't want to. Now evaluate. Remember, it's the top number minus the evaluation at the bottom number. Square root of 1/4 is a half. Square root of 1 over 16 is a fourth. And after I do the arithmetic, I get an answer of 1/8. And so the net area from 1 over 16 to 1 over 4 is equal to 1/8. Take care and have a great day.